Okay, I just want to take a look at this setup and see just how sensitive it is and how little electricity it takes to actually create this reaction. I have a 12-volt DC deep cycle battery, and it's connected to this pulse modulator and an amp meter, which is set to measure amps or amperage. And so what I'll do is I'll try to get this in one shot. You can see it. What you'll see is it only takes us about, I mean, we're at a quarter of an amp right there. And as you can see, that 12 volts at a quarter of an amp does produce a rotation. This is quite a bit of iron oxide off of this rod. This experiment's run for several minutes, and it begins to oxidize that rod rather quickly. It's great to have the iron oxide in the water to show us the movement. And watch what happens as I turn this up. We can get this to quite a few amps here, 2 or 3. And watch the reaction as I speed this up. The rotations also speed up. Again, we'll turn it up some more. That's a little over 2 amps. Quite a good bit of speed there. We'll take it on up to 3. And you can see that just a small amount of current creates a massive amount of motion in this water, salt water, all the way through the column. Now, just for fun, we're going to try this with 36 volts. So this last test will be run at 72 volts. And you can see the indentions in the water because the rotation is so strong. And you'll see multiple vortices around the electrodes as these rotations break away from one another. 72 volts, ladies and gentlemen.